Here is the next video on the Ohm's law and its application. So here he's asking about find the individual current passing through each resistor, voltage across each resistor, and power consumed by each resistor. Okay, so basically the question he's asking about find I1, I2, I3, V1, V2, and V3, P1, P2, and P3. These are the quantities he's asking us to find. Same thing with the parallel circuit. So these two are two different examples, but I'm doing side by side so you can compare what's going on when we connect them in series, when we connect them in parallel. Now, so in series, what is the R total? R total must be R1 plus R2 plus R3. Since he didn't label the resistance values, I'm going to label them R1, R2, and R3. I'm going to label the same numbers R1, R2, and R3. So R total equal to 10 plus 20 plus 30, that is 60 ohm. Okay. Now, can we find I from there? I equal to V over R total, which is 120 over 60, which is 2 ampere. That's the current passing through this circuit. Okay, 2 amperes. So the same 2 ampere is passing through each element because in series current is same. So I1 equal to 2 amperes, I2 equal to 2 amperes, I3 equal to 2 amperes. So the point we know here, same current in series circuit, current is same, I is same in each element. Okay, so from here I found I in the circuit. Okay, now here R total, so when they're in parallel we're going to use 1 over R total equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so here it is 1 over 10 plus 1 over 20 plus 1 over 30 equal to 1 over R total. Okay, if you combine these, you will end up with 1 over 5.46 ohm, or you can say 5.5 ohm approximately. So R total equal to 5.5 ohm. Let me keep this as 5.45 or 46. Okay, so R total equal to 5.46. The easy way, whenever you see this, doing it in the calculator is a little bit difficult. We always get confused. I saw most of the time students were writing R total equal to 1 over 5.46 ohm. Okay, which is wrong. You need to inverse it. Okay, so whenever there are two resistors are in parallel, usually when the resistors are in parallel, that's a symbol we represent. If R1 and R2 are in parallel, basically 1 over R1 plus 1 over R2 equal to 1 over R total. I'm solving a different example where only two resistors are in parallel. Okay, so 1 over R total equal to 1 over R1 plus 1 over R2. So to write it down, you can take the LCM R1 times R2, so R2 plus R1. So if you reverse it to get R total equal to R1 times R2 over R1 plus R2. So if only two resistors are in parallel, we commonly use this formula. Just multiply in the numerator and add them in the denominator. Now, if three resistors are in parallel, R1 parallel with R2 parallel with R3, okay, now R total equal to R1 times R2 times R3 over R1 R2 plus R2 R3 plus R3 R1. This is the formula when three resistors are in parallel. Okay, I saw students were writing R total equal to multiply in the numerator by adding them in the denominator, which is wrong. Okay, so two resistors are in parallel, use this formula. Three resistors are in parallel, use this formula. Okay, so now here when we solve it, our R total is 5.46. As I mentioned, it is smaller than the lowest resistance. Now we know that in parallel voltage is same, so I can say V1 equal to V2 equal to V3 equal to V, which is 120 volts. Based on this, can I write I1 equal to V1 over R1. V1 is 120, R1 is 10, so it is 12 amperes. I2 is V over R2, which is 120 divided by 20, that is 6 amperes. I3 equal to V3 over R3, 120 over 30, which is 4 amperes. So that's the total current I total equal to I1 plus I2 plus I3, which is 12 plus 6 plus 4, 22 amperes. That's the total current passing through the or supplied by the source. So see, when we connect them in parallel, it is supplying lots of current. When we connect them in series, it is supplying only 2 amperes. Now we have V1, V2, V3, I1, I2, I3. Here I didn't find the V1, V2, V3 yet. So in this case, V1 equal to, so here is my V1, voltage drop across R1, I times R1, which is 2 times 10, that is 20 volt. V2 is I times R2, 2 times 20, that is 40 volt. And V3 equal to I times R3, 2 times 30, that is 60 volt. Okay, so those are the V1, V2, V3. Now we can find P1. P1, I can say V1 times I1, which is 20 times 2, that is 40 watt. P2 equal to V2 times I2. V2 is 40, I2 is 2, that is 80 watt. P3, V3 times I3, which is 60 times 2, 120 watt. So if you look at my resistors, I have 10 is to 20 is to 30. I mean 10 ohms, 20 ohms, 30 ohms. When you look at the power, 40, 80, 120. Okay, so isn't it ratio is same? So my resistance ratio is 1 is to 2 is to 3. My power ratio is also 1 is to 2 is to 3. So in series, power ratio is same as the resistance ratio. Now when it comes to the parallel, we'll find P1. P1 equal to, I can say V1 times I1. I can use the same formula, or I can say I1 square times R1. Use any one of those two. You can find I have V1 equal to 120, I1 equal to 12. So 120 times 12, that is 1440 watt. That's a huge amount of power. P2 equal to V2 times I2, or I2 square times R2. I'm going to use V2 times I2, 120 times 6. It's half of it, so it must be 720. And P3 equal to V3 times I3, which is I3 square times R3. I have V3 equal to 120 times 4, that is 480 watt. Okay, so look at the power consumed when we connect them in parallel. It's a huge amount of power. So if you look at your incandescent bulbs, when you go to the market buy incandescent bulb, most probably you see a 40 watt bulb, 60 watt bulb, 100 watt bulb. So you can see, and so they consume that much amount of power. A 1400 watt, usually you don't see 1400 watt bulbs, but the room heater, you see a small room heater, you buy it from Walmart, it consumes around 1500 watt. So based on that, you can see the power ranges, power rating. Okay, so here in this example, you see that comparison between series circuit and parallel circuit, how the power is consumed in that circuit. Thank you.